Dear students, good morning. Today we are going to start another chapter of physics, that is work and energy, which is a very important and knowledgeable chapter. So far, we have described the motion of an object when the force acting on it is constant. This has been done by applying Newton's second law of motion, but in most physical phenomena, the force acting on object are not constant and in fact depends on their position. Such force include gravitational force or the force exerted by an object attached to a spring. To deal with such type of situations, we shall develop general method by introducing the concept of work done by a force, as the object on which it acts moves from one place to another place. The concept of work is closely related to the concept of energy. In fact, the concept of work provides a link between force and energy. It is to be noted that the work-energy approach is based on Newton's law and as such does not involve any new principle. Further, from the practical point of view, it is important to know not only the work done on an object but also the rate at which it is being done. This involves the concept of power. Now come to work. The intuitive meaning of work is quite different from the scientific definition of work. In everyday activity, the term work is used equally for mental work and physical work. If you are doing something, if you are doing some mental work, you may get tired. But according to physics, you are not doing any work. If you are standing on a platform with a heavy suitcase on the platform, but you are not moving, it means you are not doing any work according to science. This is a wall. If a person is applying some force on this wall, but that person unable to produce displacement in this wall, then that person is not doing any type of work according to physics. But himself, he is doing some work. But on the wall, his work done is zero. So, work is said to be done. You are doing work only when you are applying some force on an object and you are able to produce displacement. Suppose this is a duster. I am applying some force on this duster and this duster is moving from one point to another point. It means I am doing some work. Suppose there is a box. I am applying some force on that box and I am able to produce displacement in that box. Then I am doing work. So work is said to be done when force applied on a body produces displacement. Otherwise, we are not doing any work. So the work done by a force is equal to the product of force and displacement. So work, it is the product of force and displacement. Consider a body A. I am applying some force F on this body and this body displaces through a distance S as shown in this figure. So work done is equal to F into S. So now come to units. Units of work, unit of force, Newton. Unit of distance, meters. So unit of work is Newton meter, or you can say this is equal to joule. 1 Newton meter is equal to 1 joule. Now come to what is 1 joule. Define 1 joule. Define units of work. So look at this formula. W is equal to Fs. 1 joule, 1 Newton and 1 meter. So look at this formula. and you can define yourself 1 joule. Work is said to be 1 joule when a force of 1 Newton is applied on a body and produces a displacement of 1 meter. So once again, work is said to be 1 joule. हम वर्क को 1 जूल कब कहेंगे? जब आप किसी भी बॉडी के ऊपर कितनी फोर्स लगाते हो? 1 न्यूटन, और उसमें डिस्प्लेसमेंट कितनी आ जाती है? 1 मीटर. So work is said to be 1 joule when 1 Newton force is applied on a body and produces a displacement of 1 meter. So there are different type of work: positive work done, negative work done, zero work done. So different situations. First of all, positive work done. Positive work done. Force, and this is a displacement. When force applied on a body, then displacement is also produced, but in the same direction. When force and displacement both are in the same direction, then there is a positive work done. When the direction of force and the displacement both are same, then there is a positive work done. Suppose this is a box. I am applying some force on this box, and the box displaces in this direction. In which direction I am applying some force? So direction of force and displacement both are same. मैंने बॉक्स को इस तरफ पुश किया तो बॉक्स उसी डायरेक्शन में जा रहा है. दोनों की डायरेक्शन सेम है, फोर्स की भी डिस्प्लेसमेंट की भी. तब कौन सा वर्क डन है? देन देयर इज अ पॉजिटिव वर्क डन. कई बार क्वेश्चन आता है, गिव प्रैक्टिकल एग्जांपल ऑफ पॉजिटिव वर्क डन. देन यू कैन गिव दिस एग्जांपल, पॉजिटिव वर्क डन. नाउ कम टू second one is negative work done. Negative work done. Suppose I am applying force in this direction and displacement is in this direction. Both are in opposite direction. मैंने force इस direction में apply की और body उस तरफ move कर दी. जैसे frictional force है, is an example of negative work done. Body is moving in this direction. Frictional force is called into play in opposite direction. And this is a chalk. I am throwing this chalk in upper direction. Displacement of this chalk is in this direction, but the force of gravity is acting downward. So displacement in this direction, force of gravity is in opposite direction. So there is a negative work done. Third is zero work done. Zero work done. ये कब पॉसिबल होगा? जीरो वर्क डन. When there is an angle of 90 degree. When there is an angle of 90 degree between the force and the displacement. So suppose a person is standing on a platform. Suppose a coolie or porter is standing on a platform. He is moving in this direction, but the force of gravity is working downward direction. So there is an angle of 90 degree between the displacement and the force. So work done is zero when there is an angle of 90 degree. So positive work done, negative work done, zero work done. So there are number of example of positive work done, negative work done, zero work done. There is one more thing is work done against gravity. Work done against gravity. So work done against gravity, it is equal to weight of the body, multiplied by vertical distance. weight of body multiplied by vertical distance. Weight, work done, weight of body, it is equal to mg, because weight it is equal to mg, vertical distance into h. So work done against gravity. If you are lifting a bucket full of water, it means you are doing some work against gravity. This is a duster, I am lifting. So we are doing some work, I am doing some work against gravity. Then you can use this one formula for numerical purpose. W, it is equal to mgh, because this duster is going up against gravity. Then you can use this one formula. W is equal to mgh. Mass is given, the value of g you know, 9.8 meter per second square, into vertical distance move, इसकी height, इसको आपने कितना लिफ्ट किया, 1 meter, 2 meter, 3 meters. So you can use this one formula for work done against gravity. So once again, first of all, work, the formula of work is this one formula, W it is equal to Fs, force into displacement. This formula is also very useful for numericals. Come to units. Units of work is Newton meter or 1 joule. After that, define 1 joule. Work is said to be 1 joule when a force of 1 Newton is applied on a body and produces a displacement of 1 meter. Different type of work, positive work done, when there is a positive work done, and examples, some practical examples. Now come to negative work done. What is the negative work done? When it is possible, and come to some practical examples. Zero work done, when there is an angle of 90 degree between the displacement and the force. And there is one more thing, work done against gravity. Remember, work, it is equal to weight of the body into vertical distance moved, and you know weight of the body, it is equal to mg. So weight of the body is equal to mg into vertical distance, let it be h. So W, it is equal to mgh. If you are doing some work against gravity, then you have to use this one formula. Thank you.